What's up, YouTube? It is me, John Bond, and I've been working hard today. I'm working a lot on this, which is my Raspberry Pi, and I'm trying to get this integrated with my Arduino. And as you know, I am building some drones. It's a project we're working on. Started out with this guy, but moved on, and what I've got done today, I've got this much of my drone working right now, so I'm going to go ahead and let you see it. This right here, whiteboard right here, it's called an H-bridge. It's basically a cheap way to make a $20 motor driver, which you can buy pretty simple for Arduino. They're 20 bucks. Instead, I spent about $2 and made my own H-bridge. Taught myself all about electronic engineering because I had no idea how to do this. So basically, I've got this H-bridge. It's being controlled by my Arduino. Got a power source which directly powers my motor right here. And what does this guy do? Well, I'm about to show you right now what this guy does. He doesn't do a whole lot right now because I still don't have a ping sensor for him. But as soon as I get a ping sensor, you know what? I'm all tangled up here, so hold on just a second. As soon as I get a ping sensor, I'm either going to go ahead and buy one. They are also 20 bucks for the ultrasonic ping sensors. I'm either going to buy one or I'm going to build one myself, which you can also do. So this guy doesn't do a whole lot right now. He's not a really cool drone because he doesn't do a lot, but the motor control is actually working. So all he does is he'll go forward for a little bit, and he'll go backward for a little bit, and he just keeps doing that over and over and over again. I understand that it's not anything real special or anything, but he does have a controller that controls him and lets him go forward and reverse, which is what the H-bridge actually does. So what we're going to do now is we're going to grab this guy. Come here, dude. Come here, buddy. And we're going to turn him off. And I'm going to go ahead and show you how to make this H-bridge, should you want to make one yourself. So let me get a breadboard out. Alright, here's the code for it. You may not understand that, but I will put the code up, show you exactly what the code does. Let's see if you're able to see this right here. So this is basically what we're going to build right here, which is an H-bridge. You can see in the diagram here how it's actually working. So all you need to build this guy is you need some transistors and you need some wires is all you need. And it's pretty simple. So you need 4 transistors because in order to control your motor, if you give the positive side the positive and the negative side the negative, it will go forward. If you give it reverse, if you give the positive side the negative and the negative side the positive, it will go backwards. So you need 4 transistors basically to operate as switches to decide which way it's going to go. So basically you're going to take 4 transistors, you're going to put them in your breadboard like so. Doesn't really matter where you go. Once you get everything wired out in your breadboard, then you can go ahead and solder and make a prototype board, which I'm also going to do later on, but I'll have to get somebody with an actual video camera and not use this little webcam to come in and make that tutorial, so you'll actually be able to see it. So as you can see, I'm just aligning up my transistors just like they show in there. You do have to bend the pins a little bit in order to get them to go in there. So here we go. So now I've got all 4 of my transistors plugged down into my breadboard, and from here it's pretty simple. So we're going to assume that this empty cable right here is going to your power source, and let's also make a couple more assumptions. Let's assume if we can actually find some more wires in here. Let's assume that this green cable right here is going to go in here to your ground. So now we've got it grounded. So basically all we want to do is we want to grab some more cables. We want to hook the 3-pin, which you can see on your diagram, which if you have it sitting this way, your first pin is your 3 pin, your middle pin is your 2nd pin, and your pin on the right side is your 1st pin. So left pin is your 3 pin. It needs to go into your power. This guy here, your 1 pin, needs to go to your ground. Remember, these are NPN transistors. So your next relay, same thing, pin 3 goes to power, so it goes to 5 volts or whatever your power source is. And on transistor 4, pin 1 goes to ground. Okay. Then all these middle pins, every middle pin is going to go to a corresponding pin on your Arduino board. You want to put it in a digital pin so that you can write to it. You can either turn it on or off. So that's all where these guys are going to go. These guys are going to go straight to the Arduino board. I'm on my Arduino board. I'm using pins 7 through 4, and that's just because if you look at this actual code up here, this port D controls pins 0 through 7. So you can use port D and you can give it binary bits. You can give it 1 byte, you can give it 8 bits, and it will trigger all 8 of your pins if you want to trigger them at the same time instead of having to write a digital write with your pin number and high or low. This way you can set a 1 for high and a 0 for low. Just make sure you always have pin 0 and pin 1, which are your receive and transmit data pins. Make sure you always have them set to 0. So all these pins here in the middle, these 4 pins right here are going to actually plug into your Arduino. And then we need just a couple more pins. So the first 2 transistors, those pins, so on transistor 1, pin 1, and on transistor 2, pin 3, that corresponds to positive and negative. So you can plug those in anywhere else on your board. You can actually come all the way over here and plug them all the way over here. That corresponds to positive and negative. And so yellow is actually the positive. And then on this guy, on transistor, let's just do transistor 3 first. On transistor 3, you plug pin 1 in. Pin 1 will go where pin 1 plugs into the same line where the pin from transistor 2, where pin 1 from transistor 2 plugs in. You want to plug in pin 3 on transistor 3. And on transistor 4, you want pin 3 plugged in the same spot where pin 1 is plugged in. So basically, you get something like this. Here's 1 and here's 2. Here's 3 and here's 4. This is the negative, or this is the power. This is the ground. This is the power. This is the ground. So you got power on this side, ground on this side. This is pin 4. This is pin 3. So this is power. This is ground. This is pin 1, which is power. This is pin 2, which is ground. So if you turn on transistor 1 and 2, basically what you're doing is you're turning on power here and ground here. If you turn on transistor 3 and 4, you're turning on ground here and power here. So if 1 or 2 are turned on, then you're going forward. If 3 and 4 are turned on, you're going backwards. So it's just like what you got going on right here. It's the same thing. Just the only thing you want to remember here, okay, there's only one big key that you want to remember here, and that is if you are running an external power source, like I am, if you've got a battery, an extra power source that's going to power up your motor, and you're not getting your power from your Arduino board itself, what you need to do is you need to get rid of this red cable right here, and where this red cable is, you need to plug in the red or the negative side of your power source, and you need to leave the ground on your Arduino. You have to leave the ground But right here next to it, or anywhere along here, you need to plug in the positive of your battery. So your battery's grounded in the same spot that your Arduino's grounded. You don't have any 5 volt or any 3 volt. You have no power coming from your Arduino board. You have your power source coming from your power source right here. There you go. You have a basic H-bridge. You're going to save yourself about $18 making those, as opposed to going and buying a motor driver shield for Arduino. We're actually going to have to make 6 of these because we need 2 for our ground robot and we need 4 for our quadcopter that we're making. We're going to 3D print the frame of our quadcopter. There'll be a lot of tutorials showing you that whole process. The next tutorial that I'm going to make is I'm going to make a power converter or a power regulator so that you can regulate the actual power coming into your motor here. So you can you regulate the voltage, and what you're regulating is the speed of your motor. So what we're going to do is we're going to make a regulator to regulate the voltage so that our autonomous robot, our drone, can decide how fast it wants to go based on the ping sensor, based on the information that he's getting, how far away an object is, or if there's anything in his line of sight. He needs to be able to decide whether he's going faster or not. And he's going to make a map while he's driving around. And if he's already mapped out the area that he's in and he needs to go to a new area because that part hasn't been mapped and he's kind of stuck in a part that's already been mapped, he needs to be able to get over there faster than the speed that he's going to drive when he's mapping. So that's it for this tutorial. Now you know how to make an H-bridge. If you don't know or have any questions or want the actual code itself, just give me a shout out either on Facebook or on YouTube, and I will definitely hook you up with that. Y'all take it easy.